Good morning. Hi, I'm Jeff Schomay, and I came in from Denver, Colorado, where I work on Pivotal Tracker. We're one of the sponsors of the conference. Thank you. We do a little bit of Elm in production, and it's awesome. So this is a profile picture that I have on my Twitter and my GitHub and my Slack account. And I just want to answer the question, yes, that really is me up on the unicycle. I want to share a story about how I took a framework that was very rigid and turned it into something very flexible. I'm talking about the Elm Narrative Engine, which is a tool that I built about a year ago for telling interactive stories. I'll give you a quick introduction to it. The basic idea is, as an author, you load a story config, which is just data that describes your manifest, which is all the items, locations, and characters in your story world, as well as some rules that describe how the story changes over interactions with the story world. And you send that into the framework, and it will create something that looks just like this, an interactive web app where a player can go through and experience your story. And one of the cool things about this is that it's not just branching and making choices, but it's context-based and context-aware, which means if you interact with something, it will respond based on the current state of the world and what you've previously done. And sometimes if you go back and interact with the exact same thing at a different time, it'll have a completely different result. And this is achieved through these rules, which are declarative and designed as data. This is an example. You specify what the trigger is for this particular rule, and you list out some conditions that need to be present for this rule to apply. And if the rule matches, you specify the changes that you want the engine to make in the story world, and you can provide some narration as well. And the engine will go through these rules. You provide sets of these, and it will pick the best match for any given time whenever there's an interaction. And that's how you play through a story. And I'm going to give you an example of what one of the stories from the first iteration of the engine looked like. This is what every single game from the first iteration of the engine would look like. At the top is the current location where you are, and you can see the different characters and the items that are in that same location with you. These are the locations that are known, and there's an area for inventory, and the story plays out down here. In this case, this is the story of Little Red Riding Hood, and I'll just play through a little bit to show you how it works. So your mother tells you to bring a basket of food to your grandma and not to talk to any strangers on the way. And so we can interact with whatever's around us. We can go to locations. So if we try to go to grandma's house, then the story says, don't forget your basket of food. Okay, so we'll grab the basket of food. You can see the story updates, and it's gone into our inventory. And if we try to go to grandma's house now, the mother says, don't forget your cape. So we'll take the cape as well, and let's try to go to grandma's house again. And now the story says, well, you can't go straight there. You have to go through the river and through the woods. Okay, so we'll go to the river, and you can see that the location changed, and what is in this location changed as well. We get some more story. We can continue through the woods where we meet the wolf, and the story goes on. You know the story. I'm going to stop here, but I have a link at the end of all of the demos that I have today, so you can play through them later on if you'd like. So that's how the story started. And I had some designs in mind. This is a slide from the last Elm conference talk where I spent a long time talking about control. And my idea was I wanted story authors to be able to focus on designing their story instead of writing code. And so I made the framework handle as much as possible and let the story authors just define the story data and pass it in as configuration, and the framework would do everything else, which is why they all look the same. And it turns out that people wanted to do more. Immediately after I released this, people asked me questions. They said that they wanted a different layout. They didn't need inventory, or they wanted it to scroll up instead of down, or they just wanted to do their own thing. And it wasn't designed to do this. In fact, that was the opposite of how I designed it to work. At first, I tried to please everyone by changing the view and trying to make it work, but obviously that wasn't ever going to solve that issue. And at the same time, this is one of the largest competitions for interactive fiction, and it was historically known for accepting only one type of interactive fiction stories, which were very heavily text-based. But over the years, they started to accept other formats. And this is the winners of the last year. And one thing that I noticed that was very interesting was of the top 10, the majority of them were heavily customized and heavily stylized. And I personally found that that customization made the stories more interesting. And apparently other people felt the same. So I realized that customization was in and control was out. But I had a problem. This was opposite of what I designed it for, and so how could I take this framework that was very, very rigid and start breaking it apart? So I got into the code. It started out like the top here, where you would provide your story data, the manifest and the story rules, and the engine would just give you an Elm program, and that was it. You obviously can't do anything with that. So the very first thing that I did was an inversion of control. You still pass in the story rules and the story manifest, but now it would give you the familiar model, update, and view. And this is basically the component pattern. And it meant that the client could now call your code. Instead of the framework running your code runs the framework. And it's kind of weird, the framework as a component. It seems backwards, but it works. Although it doesn't really accomplish much because it's still just as rigid as it was before. So I had to go further. I realized that the engine didn't need to really handle the view at all. The important thing that the engine needed to care about was knowing about the story world, which is where things are, what the current location is, what items are in inventory, that type of stuff. And it didn't even need to know the information to display these things, like a name or a description. It really just needed to know these IDs of where everything was. And it also needed to be able to take a bunch of rules and do some logic to find the correct rule that would be the best match and apply it to update the world. And that's really all that the engine needed to handle. And the rest of the job of showing this in an interesting way could be left up to the client. So the first thing I did is I pulled out the view function completely. It's just gone. I still have an init and a model, which I need. The update function got a little bit simpler because I didn't need a custom message type. All I need to do is give the ID that you interact with, and then the engine can do that logic and give you a new version of the model. And all that was left was to provide some accessors so that the client could get the information that it wants to display. And so we turned the engine from first a framework and then into a component and now into a module, just like a regular library. And this is very interesting because it totally separates the logic from the presentation. And that's powerful because it means that the client is free to do whatever it wants. And now if people don't like the layout that I had selected, they can write their own. If they wanted to scroll down instead of up, they can do that. And I want to point out, I mentioned that I took all of the display information out of the engine. And so when you call for the items in the inventory, you get a list of IDs, and it's up to the client code to turn that into something that you can display. And so the manifest initially would have all of the items and locations and characters in your story. It would be the ID associated with this display information. It would strip out the IDs to send that to the engine so that the engine could hold that stateful part of it. But the rest of the config is just static, and when you get the IDs back from the engine, the client has to perform a lookup to get that information. So there's no duplication of state. There's a minimum amount of state held in the places that make the most sense, and it worked out very well. It made it possible for writing themes or just for the client code to write whatever it wanted to do. And there's lots of things that we wanted to do. Now that we can create stories that look however we want them to look, we want more power. We want to be able to change what it means to write a story. Maybe if you're familiar with Twine stories, you want to try to write a Twine story, which wasn't really the intention, but that you might want to do that. Or you might want to have audio narration or 3D or whatever crazy things you can come up with. And because the client is in charge of the presentation, it means that it can do whatever it wants. And I wanted to point out as well that because this is running in the client code, there's a whole, whatever the client app is, can sort of intermingle the information from the story with whatever the client app wants to do. And so you can combine pieces of the story and pieces of whatever your app is and get very creative that way. But it also means that there's more complexity on the client. And so I discovered this interesting pattern which works out very well with the new way that the engine was structured. It's called the Entity Component System pattern. It's used often in game development and also in some editors like Unity, if you're familiar with that. And the basic idea is all of your objects are an entity, and they're as simple as just an ID. You can kind of think about it as a database row. And if you need some data to go with it, like the display information that I mentioned, you would create a component. This is the display information component, and it would have the data that is important for that component. And you just associate the ID of your identity that needs to have display information with that component. And then there's a system which knows how to do something useful with that data. And so in the display information case, it probably just renders that information, kind of like what you saw before. And this pattern is very powerful because its whole purpose is to loosely couple all the pieces. And this is kind of what it looks like in Elm. I decided to use dictionaries to hold all the identities, and each component that you want to associate with an identity is also held in a dictionary. So you have to kind of drill down to fetch a component out. But this allows you to add components as you need them, and they don't interact with each other, and the engine doesn't need to know about them at all. It doesn't get affected. Any component that you can come up with, you can create. Define the data that it needs, build a system that knows how to do something with that, and you just add it in there. And everything is tied together by an ID. And this is interesting because it means you could do this in code, and I'll show you an example of that. But you could also import some information. I have this idea to create a visual editor, which would just make it an easier tool to write out your stories. And you could import that data as JSON. And as long as the IDs match up, you can decode it and bring it back into the system, and that would work. But you could also, if you needed to, perhaps you have part of your team that is associating some data for maybe sound files or something, and they use a CSV. As long as they have the IDs that match and whatever data, like the sound files, you could import that. And align them together in your code. And the idea is you could bring in information from many different places and many different tools, and it all comes together. Now, one side effect of this is the ID becomes very important, but it became a string, which means I lost a lot of type safety. It's unfortunate, but I think it's a necessity because the data may be generated at runtime. In the case of the visual editor, it would be just typed in by the user, and so I can't type that. And I may need to transport it in serialized format like JSON. So I lose a little bit of type safety, but I gain so much in flexibility that I think it was a good trade-off. And I'll give an example of what one of these components looks like. You'll recall from the demo at the beginning, when we went through the different locations, it felt a little bit awkward. You could go to locations that you weren't really supposed to go to yet, and it was kind of confusing. So maybe you want to just show the locations that you actually can go to. And you could write rules that add locations and remove locations, but those are kind of mechanics, not story, and you might not want to concern yourself with that when you're designing the story. So this is an example of a component that knows about associating different locations. And this is something the engine was never designed to do, but it's an example of how if you need this in the client code, you can just create it. And so I have a simple component that has this concept of a location and the different directions that would connect it to other locations. And there's not much code that just pulls that information out and renders it in a way that would make sense. This is just a simple list, but you could imagine that you could render it as a compass or even a map. And so I took this idea and I tried to push it to its limits. I wanted to make a story that was more visually based rather than text-based. And so I created components that had to do with visual presentation. I have this idea of a sprite component, which has a position and a size, and I have some images, and I even found a way to do some conditional components where I could describe as data components that would find the correct variation at the time that they were called based on the current state. And I'm going to show you a demo of what this looks like, to show you just how flexible the same engine and the same story of Little Red Riding Hood can be. Here we are again, same exact story. I got these awesome art assets by a local artist, and his name is at the end. And this is all positioned. I did this in HTML because it worked for the job. And different areas in this image are interactable. And so again, the exact same story. Mother wants you to, well, we'll talk to the mother. So I click on the mother, and she says, hey, bring this basket of food to your grandma. And don't talk to strangers. And just like before, if I click on the door and try to leave, same exact rule, don't forget your basket. So we'll grab the basket, try to leave again, same rules as before, don't forget your cape. We get our cape, and now we can go. And I just want to point out that the engine was the same, the rules are the same, it's just the client can do almost whatever it wants to tell the story in a different way. Here's where we meet the wolf, and I'll keep playing this time. The wolf, of course, wants to ask some questions, and we can decide if we want to respond or not. It's more interesting if we talk to the wolf, so I'm going to do that. Little Red Riding Hood says, oh, I'm going to my grandma's house. And the wolf says, thank you very much. And by the time we get to grandma's house, something is wrong. Little Red, and there's some more texture in here. Like if I click on Little Red Riding Hood, there's some more layers of story, so I'm just taking the simple path. But you could play through this on your own. I'll give you the link later and explore it more. But why your eyes? What big eyes you have, and what big ears you have, and what big teeth you have, and that's why you don't talk to strangers. Thank you. I just want to shout out to my artist, Samuel Erb. He did an awesome job on these graphics. So yeah, that's the example of where you could go with this. And that could be great just there. But now that I had this system that was so flexible, I kind of wanted to play with it just a little bit more. And I was wondering, what else can I do? And so recall how when I created those sprite components, I had to figure out the position and the size. And that's a little tedious. I was sort of like adding numbers to the width and making sure that it would line up. If there were a tool that would let me visually position these sprites, that would be so much easier. And then I could import that format and parse it and, as I mentioned before, associate it somehow by ID. That would be easier. And it turns out there are such tools. There's a few of them out there. So I started going down that path, and this is another example of a tool called Tiled, which lets you build tile maps. And it positions all these different tiles at different locations, but it also can be used to represent these tiles are solid, so you can't go through them, and you can use them as in your physics system to have collisions. And I realized this is going to be a lot to parse, and I need to have some kind of engine in Elm that knows how to do physics now. And obviously that would be possible, and we saw earlier that there's some games that are doing this. But I knew about this other engine called Phaser. It's a JavaScript game engine. It works really nicely, and it knows how to import these files from Tiled, and it handles the collision and all that for you. And so I had this idea that perhaps I could use Phaser to run the game, do the physics, do the animation and all that, but maybe I could still use my narrative engine just for the narrative element of the game. And so the idea was I would take the engine as it was. I didn't make any modifications. And in the client code, I didn't need a view anymore because that was handled by Phaser. So I got rid of the view, and I just had a very thin layer of ports going out of Elm, which would have on an interaction and giving the state of the world. And I could connect that to my Phaser code, again, with a very thin layer. And the idea was I would design the levels in Tiled, and whenever I had a collision, I could associate data with the, in Tiled, you can just create any type of property you want. And so you can see that I created an ID field which has that same ID that the engine knows about. And so whenever there's a collision, I send that ID over the ports into Elm. My narrative engine runs that same update code, figures out what the current state is, and sends that back to Phaser, and Phaser updates what it's displaying appropriately based on that. This was the idea, and so I played with it. And it turns out it worked. And I have a demo. Here we are again, the story of Little Red Riding Hood. And I control Little Red Riding Hood. And so Mother again says, bring this basket of food to Grandma. And just like before, if I try to leave, don't forget your basket. Oh, actually, I have to go talk to my mother first. She says, hey, bring this basket of food. So I try to leave without it. Exact same rules as before. Don't forget the food. Grab the food, and now I can go. And the point is, same engine, same rules, but I was able to use these other tools. I used Tiled to build the map, and so it was a very visual process of designing the level, and I was able to use my rules to build the game logic and the content. And what was interesting, my original goal was to allow story authors to write their story without having to write code. And it turns out that by making the engine more flexible, actually made it more possible to spend your time in these visual tools that are just a much better experience for telling stories. And so I achieved my original goal by getting rid of that control, making it very flexible, and making it possible to integrate. And it worked out great. So if you want to play these games on your own, this is the link to be able to play them, as well as you can look at the code. It's not that difficult of code. And if you want to write your own stories, there's a link to the story starter, which you can just clone and modify however you like and get going immediately. So thank you very much.
Thank you so much, Jeff. Does anyone have questions? We'll take like 2 questions. Yeah.
Yeah, it was very interesting, thank you.
Thank you.
I also played around with Phaser before, but before I knew Elm or anything. So how much code did you have to write actually in Phaser and JavaScript to make the walking around and such?
Yeah, how much code do I have to write for that? Not much at all. I have a very thin, basic, a level that knows how to handle arrow keys and move the character, which is like 20 lines of code. And then I have a few functions to wire together the signals from Elm and loop that back into Phaser, which is maybe another 30 lines of JavaScript. And then the rest of it is just pulling in the different image assets and map assets. So not a lot. And when you're building the game out, besides importing the assets, there's no logic-based code that you have to write.
Another question? No. Okay, thank you very much, Jeff.
Thank you.